Right, guys, so let's quickly go through the review of some of the challenges. Many things today here to talk about, right? All right, so on the lower beginner, is there any question in particular you want to review? If not, I will pick just one of the... That's mobile, yeah. I'm wondering if I select the right one. Ah, no, so that's lower intermediate, sorry. Yeah. So that's lower intermediate. So that's the quiz game using on the intermediate level. Let me try to move my face, hopefully. Here you go. I can do it now. All right. So now you can see the four options, right? So find the word in capitals. We want to see if a word is written in capitals or not. A, B, C, or D. A. Gideon. No. D. Yep. That's correct. So a word will be in capitals if the word is the same as the word converted to uppercase, right? And finally, let's pay attention to the exercise. If there are no words in capitals, we should return an empty string.
So all operation? No.
Say it again?
Do we need to use the all operation?
Maybe. You tell me. Yeah. How do we say it in JavaScript? If there is something, return it. If not, it's A. That's correct. That's the OR operator. That means if you have a capital word, return it. Or, like the otherwise, then return an empty string. Does it make sense?
Mm-hmm. Can you do that in React as well?
Yes, you can. Yeah, of course. Yeah. All right. So next question. Oh, higher order functions. I think we're going to do a couple of exercises about that today. Yeah.
Can we have a look at the question on the tennis players?
The what?
The question about the tennis players.
Tennis players. Is it on this challenge?
I don't remember.
We'll see. If it's,
Okay.
I don't think it's on this challenge. I think it's on the intermediate or upper intermediate, one of these. All right. So transform. We got a function, and once again, as you can see, I think it's missing part of the answer, right? Is it? Sorry. I need to refresh. All right. Yeah, because I changed the resolution, right? Yeah. So that type of thing is a bit experimental. Yeah, so just give me a second. It has a funny behavior now. All right, so let's see if it works now. Yes, you were right, Gideon. We need to refresh. All right, so let's talk about higher order functions, right? So we have a function that receives as an argument another function. So then what? Then we should invoke that function passing a number. Which number do we have to provide? So once we multiply that number by 3, it returns 12. 4, that's correct, Joshua. All the options talk about number 4, so it's not that obvious. So which one should we select? Why A, Gideon? That's a good point. It's the only one that returns something, right? So that was pretty simplistic. But even if some of the others will return it, what we return the result of calling that function. So the result of calling this function, passing number 4 as the argument, right? What else? Let me try to see if we got the Grand Slam question here. I don't think so. So probably, unless you want to do any of these questions in particular, I would like to jump to the next challenge. That was pretty easy, right? So the next challenge, if it works, oh God, what's going on with my laptop? I don't know. So next challenge was intermediate, placeholder, right? I'll once again try to use mobile view and see if it works. So what do we got here? So first question, looks like we're talking about the rest parameter or the rest operator, right? So how many arguments our getMean value receives? One, that's correct. What type of data we receive? An array. Nice one. All right. So, can I zoom in a bit more? Yes, I can. Brilliant. So then what? Get minimum value. We receive one argument, right? How would you call the argument? Array? Can we call it numbers or values? Yeah? Get min value, give me the list of values. So in JavaScript, how do you get the minimum value of a list?
Mass.min.
Fantastic, you should method min, and then can we do that?
Then we need the 3 dots.
Why?
Because we're using the rest operator.
Yep. Yeah.
No, because like we don't know how many values are going, how many elements are going to be in the array.
That's correct, Jose. So does method min work with arrays? Can we pass an array here? No, we can't. Unfortunately, that doesn't work in JavaScript.
But we can do, apart from that one, we can use
Apply.
Met.minimum dot apply, then use some 0 and then passing that array.
So where do you copy that from? Stack Overflow?
No, not Stack Overflow.
This sounds very, very old way of solving the problem compared to the rest parameter, right?
I think these on the WP school, there are some examples.
Fine. I will never approve a pull request of someone doing that, right? Before having the rest parameter, fantastic. There were very romantic ways of solving the problem. But now, thankfully, let's just use the 3 dots, right? All right. Let's see if it works. Fantastic. Confetti time. All right. What else? Transform numbers. Another. Actually, that's the same question, right? So I'm going to skip it. Find the shortest word. That's a good one. So we receive a sentence, and we want to find the shortest word on that sentence. Something you may find is that sometimes the placeholder challenges are even more complicated than the row challenges. Because when you code by yourself, you start from scratch, and then you select your strategy. But here we're already telling you, please complete this algorithm. Yeah, we are narrowing your creativity. But anyway, I think that's important as well, right? If you have to review what your colleagues have done, probably you're in a good position to say, please rebuild everything using a for loop instead of for each, right? So you need to just adjust yourself to what the circumstances give you. And this is a good example. So we want to find the shortest word. What we got so far? So with a string, I find that name particularly horrible. We should call it probably sentence, but anyway. Split, so that will give me an array of words. And then reduce. So with reduce, we can iterate, right? We can go through each loop, through each element of the list. So there is a condition. If something, then something. Else, something else. So what's the condition? The condition is my word, is the length of each word smaller than whatever the smallest word was? So can we do word dot length small than shortest dot length?
Yes, but would you need to put return before? Or is that implicit?
It's a good question. Do we need to put a return? The parentheses, look. Because you have parentheses if you drop a return. Oh god. Oh. If you put a return statement, you'll break it. Add won't work. Oh god. Remember guys that oh god, that's interesting. If I go left, it changes the slide. I cannot do that. Alright, yeah, I'll fix that. Cool.
So it would work with the curly braces.
If we replace the parentheses with curly braces, then we need to put the return statement.
Okay.
But with the parentheses, no return statement. All right, so if word of length is smaller than shortest of length, what do we return to the next iteration? Word? And if not, that's correct. So shortest, this is the accumulator. You remember the accumulator? Using reduce, shortest will keep whatever value we keep passing. Do we need to initialize the reduce loop? Do we need any default value?
Start from index 0.
That's correct. Remember guys, if we don't provide any default value, what will be then the default value of the accumulator of shortest? Correct, the first word. And then what will be the first value of word? The next one with the second element of the array. So we are saving one iteration, right? All right, so let's see if it works. We get confetti, right? Nice. Ah, the Grand Slam, that's the one you wanted, Joshua.
Yeah.
So, look, we got a function that receives one single object with the details of a tennis player. So we want to see how many Grand Slams that player got, which will be essentially the result of adding all these numbers, right? Cool. So, what we got so far? Grand Slam count, obj.values. So obj.values players.report, that will give an array, return array of 6, 1, 8, and 5. So once we have an array of 6, 1, 8, and 5, how do we calculate the total? Well, simply with reduce, right? So you can have total, comma, and then count. I'm not sure how to call that, to be honest. So it's that number. Or victories. Yeah, we need to make the placeholder a bit longer. Let me call it count for now. Now, you need to be a bit careful. No, ignore me. Oh, sorry, that's a bit confusing. All right. So now, what do we put here? Say it again? Total plus count. Do we need to add the return statement? Do we need to add a semicolon? It will break. If I test that, it won't work. As you can see. Why? Because I got a syntax error. So when you have the parentheses, no return, no semicolon. Just the expression. As simple as that. Does it make sense? Any questions?
Could you have a look at my solution?
Yeah, I'll have a look to your solution, yeah, once we complete this challenge. Yes. All right, so find the most populated country. We have an array of countries. I think we reviewed that question already in a different challenge. So we want to find the most populated one. So this is about how do we use sort. So, what do you think?
I think we have to minus
Country B minus. Why? Because country B is an object, right? And we're going to compare the population. Country B dot population minus country A dot population. Even though that may be correct, probably you remember I told you last time I'm not a big fan of this solution. Why? What?
It's a string.
That's correct, Joshua. Population is a string. So technically speaking, do you remember how to transform a string into a number?
Plus, we use the plus sign.
You can either type number explicitly, or, as you said, Joshua, you can do that, which is, sorry guys, that's a bit confusing. That's a very sexy way of transforming a string into a number. Yeah? And that's it. Let's see if it works. That's it. It does work. All right. So, that was it in this challenge. So let me quickly check your solutions, especially Joshua's one. If anyone is interested, of course, we can go through that as well. All right. So Grand Slam count. Here you go. Why it didn't work for Joshua, guys?
Something to do with the parentheses.
Once again, the return is wrong. So the return statement, same as the semicolon, is only allowed if you put the curly braces. If you put parentheses or nothing, which is the same, parentheses and nothing is the same, you cannot put the return statement.
Double quotes and after radius, after the radius.
Double quotes, you mean double parentheses?
Yes.
Well, doesn't help neither, right? But yeah, but okay, but that's pretty obvious, right? But this is not that obvious. You cannot put the return statement.
Okay.
Anyone else wants to check anything on his or her code? No? Cool. So then let me quickly go to next challenge. That was the upper intermediate, right? Things start getting a bit more complicated here. And based on these scores, probably you're going to appreciate this session. All right, so what we got? First of all, let me, I refresh, so probably need to start again. Yeah, here we go. And now hopefully that should be it. All right, add the positive numbers. So easy, right? We've got an array, a list of numbers, just keep the positives and add them all. So let's create a variable as numbers. So then return, there are two ways we can solve that. One using filter, one for each, yeah, of course, and for, and map. Many different ways we can use that. We can solve the problem. So let's use filters first. Numbers.filter. So then, what's the condition to keep a number?
Number greater than 0.
Greater or equal?
Greater or equal.
Will it matter at all?
Because 0 doesn't.
We can, if we give the 0, if we have 20 0 plus 0, but it's a bit stupid, right? So let's just get rid of them. Do we need the return statement? No, because we don't have any curly braces, right? That's like that. And now, how do we add numbers? Reduce, correct. So with reduce, we get total and then number.
Curly braces.
I don't want to put curly braces. So how do we complete this expression?
Total plus equals number.
Total plus, or simply total plus number, because that will be passed to the next iteration. Yeah? So in other words, so if my array is 3, -1, and 2, do you remember that thingy we did? Iteration number 1. What's the value of total? sorry. It's 3. Correct. What's the value of number? Is it -1 or is it 2?
No, it's going to skip -1.
So we've already removed -1. So what's the number? 2. That's correct. Iteration number 2. What's the value of total? 4, 5, 6, 7. It's 5. Okay, so okay, that's fine. What's the number? Say it again.
2.
2 again. All right. So what's on iteration 3?
So it's none.
So there is no iteration 3. That means the result of adding all the positive numbers in that list is 7, because this is what you are returning, right? 5 plus 2, 7. How many iterations our reduced loop has? Okay, so you think it's 2, fantastic. So that means that this algorithm will return 7, which is clearly wrong. What is the problem? Because the result of 3 plus 2 is not 7, as far as I know, right? Why are you assuming that number is 2 on the second iteration? It was 2 already here. Why is it 2 again? So you think that the number will be undefined? Oh, sorry about that. So the number will be undefined. So then what's the result of adding 5 plus undefined? It's not a number, right? So that will return not a number. We're making it even worse. So the question is pretty obvious. How many iterations the reduced loop has? And if you think it's true, what's the value of the second number? That's only 1, of course, because after the first iteration, that's it, right? There's nothing else on the right-hand side. You see, that's the consequence, as I mentioned before, of skipping the default value. We save 1 iteration. Theoretically, if we will have a default value, how many iterations will we have? 2, that's correct. But because we remove it, it's only 1 iteration. Yeah? Even simpler. All right. Let's see if it works. It does work. And now, what happens if I don't want to have any filter? You see, that's not particularly performant, because we need to loop over all the numbers. Imagine that we got 1 million numbers, yeah? And imagine that every number, apart from 1, is positive. That means we have to iterate 1 million times here, and how many here? How many times? That's correct. 999,999 times. So roughly, we need to iterate 2 million times to calculate the result in this particular scenario. However, if we can skip that step, that means how many times will we have to iterate if we got 1 million numbers? Does the question make any sense? 1 million, that's correct. If we have 1 loop, we iterate only once. But obviously, that's not fully correct yet. because that will include the negative numbers. Yeah, we don't want that. However, can we set number greater than 0, then add them, else what? Total, that's correct, Montaigne. Yeah? Go through all the numbers. If I come across a positive number, add it. If not, just keep the total, how it was, right? That's more efficient. We may save 50% of the iterations. Yeah? Will that work? Oh, it doesn't work. I did something wrong. Let's have a look. So, O of you return 4. Why I return 4? Ah, that's correct. Yes. In this particular case, the default value matters. Why? What's the first value of total according to this example? Ah, so it's already wrong, right? Even if all the following steps are correct, if the default value is -1, that's not correct. So what can we do here? Simply add. Oh, I cannot type anymore. Hello? Hello? You cannot type? That's a bit weird, right? Did that happen to you at all? Yeah? I don't know why I cannot type. Anyway, if you add comma 0, then the default value of the total will be 0, and all the following calculations will be effectively taken, right? Any questions? No? All right, so I cannot type anymore. That's a bit weird. Let me refresh. Yeah, there's something not right with the typing on mobile. I don't know what and why. So on the question number 3, I believe, here you go. Switch keys and values. That's a good question. So we have an object, and the object has keys and values, obviously. So we're going to swap them. So whichever the key was, first name, now will become the value, and vice versa. Whatever the value is, it will become the key, if that makes sense. Yeah? All right. So, what's the argument name? Say it again. Person. So, is that the person? Country Portugal. It's an obvious, right? We have no idea about the semantics. If I cannot type again. Oh, that's a bit suspicious. I don't know why it happened. Yeah, so if we don't know the semantics of the algorithm, it's much better to keep it generic. Keep it object rather than person, if we are not sure if that will be a person or not, right? All right, so if it keeps failing, I'll go back to desktop mode. Yeah, now it works. All right, so I got my object. So now, this is a clear example where reduce is very beneficial. Why? Because we can do return. How do we get the keys of my object? Yeah, object.keys. Can you still see the screen? Yeah, should be right. Object.keys. Yeah, object, fantastic. And now look, reduce. So I can iterate over all the keys and I can build my new object. So let me call it swap object. And now what's the name of the second argument? That's the key. That's right, Montaigne. Yeah? Why? Because if we do object.keys object, on each iteration we'll have a new key here, right? So now, I'm going to have a default value. What do you think is a valid default value here? That's correct, guys. It's an empty object. So that's correct. So we want essentially to build a new object, yeah? And then, so we got the key, fantastic. How do we get the value associated to that key? So let value equals what?
Use bracket notation.
Okay, out of what? Object, key, that's correct guys, that's correct, fantastic, yeah, fantastic. So I got the key, I got the value, so now, can I simply do swap object? So please fill the gaps, what do I put here? I'll give you two options, key or value, correct, or Simon. Simon, sorry. Key, and then here what? Value? Will that work? Happy about it?
You need to put a return.
Okay.
It's in the bracket.
So at the moment, as Cam suggested, look, we're using brackets, right? Whenever you use brackets, eventually you have to return something. So what do we return? That's correct, Simon. Right, that's correct, but I'm afraid to tell you, you are completely wrong. That won't work. I'll tell you what what you are doing. You're essentially creating a copy of your original object. You go through all the keys, and then for each key, you create a new object and use the same key with the same value. You're creating a copy. That's not what the exercise wants. Look, if we test it, you see what I was talking about? You return first name Joseph, last name Blatter, which is wrong. Say it again, Sarah? For in, no. Did it? Yeah, I think Gray did that. I'm not a big fan of that because now the exercise is a bit opinionated about how can you solve it, right? But anyway, that's a separate story, guys. So assuming it is possible to solve the problem using reduce, so we want to swap the keys and the values. Are we doing any swapping at all? So then what? How do we swap the keys and the values? I mean, call me crazy. Maybe I'm talking bullshit now, but can I do that? Whatever the value was Joseph. Fantastic. Now Joseph is the key. The key was first name. Great. Now first name is the value. That's it. Easy peasy. And it works. Any questions? No? All right. Question number 3. Find the shortest word. We've done that already a minute ago, right? All right. Skip. Question number 4. I think it's 4. Find tokens within sentences. I'm going to skip that one as well. This is regex. I don't want to waste your time dealing with that exercise. So I would like to invite you to try with it. If you don't know how to solve it, before the end of the bootcamp, I'll give you the solution. But let's focus on the more important stuff, like this one. Once again, higher order functions. How many higher order functions do we have here on each scenario? 2, that's correct. So the first one is passed as an argument. And the second one is the result of invoking our main function. So our function returns another function. It's a bit mind-blowing. It's one of the most complicated exercises. All right, so first of all, how many arguments do we have? 2? All right, so what's the name of the first argument? function 1, I cannot type anymore, guys. I'm so sorry. I'm going back to desktop for the rest of the exercise. I'll try to zoom it as much as possible because, yeah, otherwise this is not going to work. I think I told you that VS Code is not supported on mobile, and I'm doing my best to support it, but I'm not Microsoft, right? So I cannot do all these things by myself. All right, so we're talking about question number 4. Here we go. Oh, and I can, oh, that's a bit, I cannot zoom it anymore. Sorry, guys, I know the setup is not ideal. So, I can type at least. All right, so combine higher order functions. So Nico was saying the first function is function 1, and the second one is called Nico function. And then what? So first of all, do you all agree that we have 2 arguments? Because if we are unable to identify how many arguments we have, that's it, right? There is no point of continuing with this exercise. So does anyone disagree with Nico?
Do we have a third argument?
Third argument. All right, so then Nico function, and then we also got count function, all right?
Which might not be present in always.
Okay, give me in which scenario count function is present.
The second two, not
The-
the first.
The second 2, or this 2, all right?
Yeah, that one and that one.
So okay, let's have a look to the third one. So I'm going to start highlighting code, and then you tell me when should I stop. So I want to point to the first argument only, right? So you tell me stop. Stop. So that's the first argument. All right. So now I'm going to keep highlighting, and you tell me when I should stop on the second argument. So that's the second argument. Are you sure, guys? This is not what I can see on the parentheses. Inside of this parenthesis, I can only see one function. The other one is outside. So I can only see one argument, and of course, that implies I cannot see 2, and of course I cannot see 3 arguments, only one. That's your argument. 1. That's your argument. 1. That's your argument. 1. Always keep in mind as a reference the parentheses. That tells you how many arguments you have. We have only one argument, guys. Does it make sense? I need to identify the pattern why coding stops working. Sorry about that again. Have you done the higher order functions training? Clearly not, right? You haven't. So you have a good task for this weekend. Higher order functions, this is very important. It goes without saying. I think here you go. That's it. So, combine, oh God, what the hell is going on today here? All right, so, I mean, do you want me to continue with this review? Because if you are lost determining the number of arguments, you are not going to understand anything, right? I'm going to solve it, but I'm going to assume that no one will understand it. And that's worrying 2 weeks before the end of the bootcamp. So please, higher than functions, this is very important. We have one argument, and that function returns another function. So return function. And the thing is, this function receives a number, 3, 7, or 2. All right, I'm going to call it n. And now, I had to return something. I need to do something with n. So what can be the value of n? Why 5? Because, okay, 5 could be wrong, but your point of view is, all right, so if I pass 5, then I can multiply 5 by 3. Will it work on the second scenario? If I pass 5, 5 multiplied by 2, 10. By 7, 70. Looks good. And on the last scenario, 5 plus 3, 8. Multiplied by 2, 16. Not right, not right. In other words, so that won't work. That will probably work on the first two scenarios. Not even. Sorry, it said 5, right? Not 3. Sorry, my fault. So if I test that, you see, that's exactly what we were thinking about. It works fine on the first two scenarios, but on the last scenario, doesn't work. Can anyone tell me why? If you carefully think about that, the problem here is we are expecting to multiply by this number before we execute that expression. So if we receive number 5, if n is 5, first of all, multiply 5 by 2, 10, and then add 3. Likewise, 5. First of all, multiply 5 by 7, 35, and then multiply by 2, 70. So, yeah, that's, yeah, I'm sorry guys, but I cannot continue if that's not working as expected. So once again, I got my function, return function, and that return function n by 5. So you see, first I multiply by 5. So I multiply 5 by this number, 5 by 2 is 10, and then I perform this operation. And if we test that, then it works. I mean, I'm assuming, I'm not even going to explain that much, right? Because I'm assuming that no one really understood that problem. But yes, seriously, intermediate higher order functions. There is a very good video on the platform about higher order functions. So please have a look, and if you have any questions, let me know. Also, FYI, there is a much sexier way to solve the same problem using an arrow function. Look. Yep. That line is the same as these lines. Oh, sorry. If I call the function, maybe. Yeah? That's equivalent. Let's prove it.
What do people usually use higher order functions for in commercial code? Like, what's their general purpose?
Use them as much as possible.
Is it just to optimize everything? Or?
First of all, from a readability perspective, even though that's a bit controversial, this is more readable than that because the code is shorter. Yeah?
But higher order functions themselves?
The idea behind, not about arrow functions. Yeah. So higher order functions, you use them more than what you can think about. So, for instance, in JavaScript, so this is not about React, it's about JavaScript. So you can bind key events. So if you can do document dot add event listener key down. Yeah, so we can capture user keystrokes, and then look. So can you see that this is a higher order function, right? It's a function that we declare and eventually, under some circumstances, gets called, gets invoked. Yeah? So, yeah, that's pretty much the most common scenario. Once again, if you check that workshop on YouTube, you will see many different approaches. All right, and I think that was the last question. Yeah, I think it was. Anything else about intermediate? Upper intermediate? No? All right, so let's do expert. Let me find, to be honest, I don't know what's going to be the best way to deal with it. Let me try, I don't know, maybe in desktop mode. Not sure if you can see the screen. All right. Is the screen readable? Probably not. Oh no, look, I can zoom now. That's a bit weird. It didn't work before. All right. I'll leave it like that then, because then we can handle that and hopefully it won't fail again. All right, so recursion. So I'm going to do 2 questions about recursion. This is a bit mind-blowing. I had to admit, when I was 18 years old, I remember when I went to uni, the first time I saw recursive function, I said, like, what the hell? This is very complicated, right? But the good thing about recursion is, once you understand it, then you will see how recursion is, at the beginning, the most difficult topic on expert, and then suddenly becomes the easiest one. Yeah? So it's just about getting around the idea. Yeah? So recursion is, you know, when you how to say that? If I take a picture of myself, and then I do a t-shirt with that picture, it's a picture of myself, having a picture of myself, having a picture of myself. Have you ever tried to point with your smartphone to a TV? If you take a picture to a TV, and the example was a bit extreme, and you send the screen of you do screen mirroring, so the screen on your picture is shown on the TV, and you take a screenshot of the TV, you got recursion, because you take a screenshot of a TV that is displaying a picture that you are taking. So it's like, that's like an infinite zoom, right? So recursion makes, second? Yeah, in Hollywood maybe, Inception, right? Yeah, exactly. That's the idea. That's the idea. Recursion, by definition, is dangerous. Why? Because recursion means going deeper and deeper and deeper and deeper and deeper and deeper. But eventually, you need a mechanism to stop and to go back. Otherwise, you are lost. If you never go back, yeah? So you need like a default close. You need a scenario where you exit that loop. Recursion is very powerful in this type of scenarios. When we have to calculate something like, give me the total. I mean, from a human point of view, even my mom will understand the problem, right? We got a bunch of numbers, just add them all. So the problem is very easy. But technically speaking, this is very complicated. Why? Because we don't know if the numbers are part of an object, sub-object, sub-sub-sub-sub-object. Could be anywhere, right? All right. So calculate total. So first of all, I got an object. Once again, I have no idea about the semantics, so I call it object. So now, return. Do I care about the keys? Are the keys any relevant? ABC, Trump, Johnson, Corbyn?
No, we only want values.
Yeah. We don't care about the keys. So I'm not going to use object.keys, I will use object.values. By the way, object.values was only 2.5 years ago added to JavaScript, so that's a quite new thing. And very handy, of course. All right, object.values object. So now I'm going to use reduce. So with reduce, I got my total, and tell me the name of the second argument. Say it again? Value, I like it. And I have a default value. And until you become the master of reduce, always have a default value. Because it never hurts, right? All right, so now, if we had a plain list of values like A1, B2, C3, if that was our scenario, then the only thing we had to do was return what? Correct, Gideon, total plus value. But unfortunately, it's not that simple because B could be another object. So we cannot add 1 plus that object. That will return a not a number. That operation is not permitted in JavaScript. So, say it again? If else, yes. If else, I'm going to use a ternary, which is a type of if else. So, first of all, I'm going to check if the value is a number or not. If it's a number, easy, right? So how do we know if value is a number? Correct. Type of value, number, then, if it's a number, then total plus value, right? Easy. Else, that's the difficult bit. Else, I want to add the total, whatever the total was, plus, this is the recursion. I want to call the calculate total function again, but this time, what's my object? What do I pass here?
Value.
Value, that's correct, guys. Oh.
I started doing this like
Yeah.
How can it read what calculate total is when we haven't even finished expressing what the function is? That's what I find so confusing.
Yeah, that's not. I find it.
It's just magic.
You need to get used to it, right? If you prefer the syntax, you can create a new variable, new value equals. So you focus on getting the new value, and then what do you return? Total plus what? New value, correct, yeah? I don't know, the syntax is a bit personal, right? Okay, so let's do a test. First of all, let's see if it works. Confetti or not confetti? Confetti time, right? So once again, let's do the game of the iterations. And this time, we're adding a new row, the dimension. So this is our object, right? So now, you will tell me dimension 1, iteration 1. So what is total? 0, correct. What's the value? 1 or 0?
1,
0, 1. Can you convince each other why 1, why 0?
Because the first value is A, and the key.
So the first key is A. So what's the first value associated to the first key?
1.
That's correct, guys. Value is 1. So what do we return?
1.
0 plus 1, which is 1, right? Because type of value is number. Dimension 1, iteration 2. What's the value of total?
1.
Correct. What's the value? That's our value. So what do we return? We don't know yet. We need to go deeper. So now, dimension 2, iteration 1. We start again playing with this object. What's the value of total?
So if you start again, the total is 0.
That's correct, Joshua. We start again, total is 0. What's the value?
But, yeah,
It's -1, yeah, because we started again with this object.
Okay.
So what do we return?
-1.
Correct. Dimension 2, iteration 2. What's the value of total? -1. And what's the value?
5.
5. What do we return? 4. That's correct. Iteration 2, sorry, dimension 2, iteration 3. What's the value of total? Wrong?
4.
4? Why 4? No. Wrong.
I'm
Is-
starting again.
Is there any iteration 3 on dimension 2? Of course there isn't, right? So, regarding the dimension 2, that's it. So the dimension 2 returns 4. And that means that essentially that gets replaced with 4. So can we now calculate the return here? It's 5, right? So now, is there anything else? Iteration 3 of which dimension? 1 or 2? 1 of the root 1, that's correct. What's the total? 5. What's the value? Return? Is there anything else? No, so that will be the result of our algorithm. That's the way you can master reduce with recursion. Both play really well together. Yeah?
Could you zoom in?
Yeah.
I don't get line number 6.
Line number 6. Yeah. So you are getting the new value associated to the key. The value associated to a key A is 1. That's obvious. The value associated to key C is 3. Easy. But what's the value associated to key B? We don't know. We don't know yet. We know that the value is an object. So what we do is we call the main function again recursively until we can get that value. That's why we have a second dimension. We go one level deeper. Eventually, once we start again here, we will know that the result of calling that function will return 4. And at that time, yeah?
Keep on.
No, that's it. Once we got number 4, then we can add 4 plus whatever the total was.
Which
Was 1, because on the previous iteration of the dimension,
okay.
we only had 1.
Okay.
Huh?
Now I understand what this means about recursion.
That is recursion. That's actually the simplest example of recursion. I'm not going to do the next one because it's more, the other one is a bit more complicated, but I prefer you to focus on that one. To be honest, once you understand this problem, going through the other one is going to be only a bit difficult. But without understanding that, the other one is just Chinese. All right, so question number 2. That was super easy. I think this is the easiest question on expert training. Yeah. So, how many arguments do we receive?
1.
Okay, fantastic. 1. What type of the argument is? It's a string, 1 string. Fantastic. So, let me divide by next number. So, function divide by next number, right? There we go. And then we have, I'm tempted to call it number, but I think this is a bit risky. Exactly, I agree with you, Gideon. String number, right? So at least, because I'm sure I will have to play with it a bit, I'll do it carefully, right? So now, return string number, because I want to access each individual digit. So how can we loop over that string? Split, fantastic. Split what? And the string, right? Because we want to go through each individual number. All right, And then, what I'm going to do next is, I'm going to use map, because I want to transform each digit, right? In other words, if I got 6 and 3, so then I will have 6 and 3, yeah? Then I will have 2 and 3. And then I will have 2 and 3, and then I will have 23. These are the steps. So why we got that transformation? Because we want to divide this number by the next one. The result of dividing 6 by 3 is 2, generally speaking. And on the last one, we should leave it as it is. Does it make sense? All right. So in this step map, I would like to do this, right? And before doing that part, how do we transform an array of strings into a string? Say it again? To array.
You said how do we make an array of strings into one string?
Correct. This is an array of strings, and I want to get 23 string. Join. Join what? What's the argument? Empty string again. And now, how do we transform from 23 as a string to 23 as a number? Plus, easy.
Ah. I thought you had to wrap it in a number method,
You can, yeah, definitely, you can do that.
but that plus is much easier.
You can do that, I'm not against that, but plus, I think it's much easier, right? All right, so now you see how I'm narrowing the problem. So I'm doing the easy parts first, so now I can focus on that transformation. This is going to be relatively easy. So map receives an argument, right? So map receives an array and returns another array of the same size, but we can transform each element of the array. So for instance, we got a list of countries and we want to return that list converted to capitals, yeah? France, Belgium, or in big words, right? Things like that. So definitely, I got my string digit, but obviously I want to divide it by the next one. So with map, we can pass a bunch of arguments, not only the current element. First of all, or second of all, we can pass the index. That's expected. And also array. Yeah, not sure how to call that argument. Let me call it array for now. Yeah? Why am I doing that? Well, because now I can easily divide each number here by the next one. How do we access the next number? So you say that let next string digit equals index plus 1? No. So array, and then what? Square brackets, correct, Mountain? Yeah? So I got the next one. So then, can I return string digit divided by next string digit? You have to run the number. That's the first thing. That's correct, Simon. According to the exercise, the result must be rounded. Yeah? How do we round a number like that? Math.round. That's correct. Math.round. Yeah? Cool. Nice. Anything else?
What about the last one?
Ah. So there are two problems, and you spot them already, right? The first one is what happened with the last number. We'll see in a minute. But the most immediate one is ignoring the last number. we're playing with the strings, right? String digit, string, 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 string. That's not good. That's not good. So let's transform everything into numbers, just to make sure that, you know, that we can perform proper operations. So we can, of course, we can do things like, I don't know, or adding a plus here. Yeah, should be okay. There is an alternative. You can do that.
But we already have a plus on
No.
line number 2.
No. So that plus solves that problem. But now we are not here yet. Now we're here. We're trying to divide 6 as a string by 2 as a string. It may work. It may work. Maybe JavaScript understands how to divide 6 by 2 as strings. But that's smelly. I don't want to trust JavaScript ability of considering me stupid, right? So I want to make sure I do it right. So string digit. Look, we can do that. As an example, like AA. First of all, transform all my strings into proper numbers. So I'm adding a step in between, right? So yes, of course. Yeah, that's correct, Montaigne. If you want, you can do that. Even easier. Yeah? Or, as we mentioned before, you can just add a plus here. Anyway, it's just to see different alternatives, right? Let's leave it like that. Now the second problem. What happened on the last index? So when index is 1, can you tell me what's the value of next? Actually, now the syntax is a bit wrong, right? Is that a string digit? No, that's simply digit. Yeah, it's not a string anymore. Digit and next digit. So, when we got 3, what's the value of index? That's correct, 1. So, index plus 1 is 2. What's the value of array 2? Undefined. Because it's undefined, this is not going to look right. So we need to control that. But we can easily control that by checking, how do we know if the index is the last one? Correct. If index is array.length minus 1, that means it's the last one. Then what do we want to return?
Return the thing, digit square bracket index, because we're not changing it.
Digit square bracket index. That won't work. Digit is number 3.
Index. Like it has to return itself.
That's correct, Sarah. If we got number 3, hey, just return it. We don't care, right? This is what the exercise is telling us. The last element must be returned as it is. So we are not going to do any magic on the last number. Does it make sense? Anything else? I think that should be it. So we try. Will it work? I'm 57% sure it will work. That's correct. Nice. All right, so that's it. I'm going to leave it here, guys. That's the other recursion question. This is a bit more complicated. It's a bit more complicated. Why? Because on the first one, we care about the total. So we keep adding. So we never look back. We got a new number, we added it. The complexity here is, so once again, it's very easy to understand the problem. Is number 3 part of that list, yes or no? But the complexity here is, on the deeper iterations, we need to know if we found the number or not. It's a bit more complicated, even though 80% is the same. I'm not going to solve it, so feel free to practice a bit. Anything else, guys? No? Cool. That was it from my side. We'll see you on the app presentation. Not sure what time it runs, but it's definitely shortly. So see you in a minute.